Good evening. I'm Spot On Weather meteorologist Matthew Euler, and welcome to my latest video presentation. And in today's video presentation, I'm going to cover another one of those oscillations that's known as the Pacific Decadal Oscillation, and we'll look at its impact on U.S. winters. On this particular image on the title slide, I'm showing you an example of a positive PDO phase, a positive one in which we have warmer than normal sea surface temperatures along the western coast of North America. And then also, you notice another area of above normal water temperatures here denoted by these brighter oranges over the equatorial eastern into the central equatorial Pacific area. That's associated with the El Nino. So on this particular year, we had both a positive Pacific Decadal Oscillation, or PDO, and an El Nino at the same time. Let's go ahead and take a look at tonight's topic. We're going to start with the agenda. In this video, I will examine the Pacific Decadal Oscillation, or PDO. We'll take a look at the definition of PDO, the various phases of the PDO, and the impacts of the PDO in association with other teleconnections. And then we'll look at the PDO along with those teleconnections, combine them, and then look at the U.S. winter temperature anomalies, combining PDO and various teleconnections. So let's take a look here. The first things first, what exactly is the Pacific Decadal Oscillation? It is a long-term ocean fluctuation of the Pacific Ocean affecting the weather patterns around it. Specifically, it describes the sea surface temperature anomalies over the northern Pacific Ocean, generally north of 20 degrees north latitude. And the PDO represents an ocean response to the atmosphere. So you have specific pressure systems that exist in the North Pacific Ocean. An example of this would be the Aleutian Low pressure system there in the vicinity of the Gulf of Alaska, right in the vicinity of the Aleutian Islands of Alaska. And the Aleutian Low, whether it's more intense or whether it's weaker during a specific winter season, is going to have an impact on how the winds flow, how the gradient sets up, the pressure gradients, and how strong those winds are. For example, if the Aleutian Low is much stronger than normal, then we tend to have a lot more southerly winds, stronger southerly winds right up along the west coast of North America. And that is going to result in that atmospheric response with the pressure system with the Aleutian Low is going to also change the sea surface temperature anomaly configuration across the North Pacific. Now, the PDO shifts between the warmer positive phases and these cooler negative phases, with each phase lasting on the order of decades. So this is a fairly longer term, let's say, oscillation, the PDO, as compared to some of the other teleconnections or climate drivers we have looked at to this point, up to this point. So let's first take a look at the PDO in the positive phase. All right. Generally, the positive phase PDO is characterized by cooler than normal sea surface temperature anomalies, denoted here in the graphic in the blue coloring. The deeper the blue, the general higher the probability that we see below normal sea surface temperature anomalies. And this, by the way, is courtesy of the World Climate Service, this graphic. It shows percentage of years having above trend December through February 2-meter temperatures. So these are the sea surface temperature anomalies over the North Pacific Ocean during a positive Pacific Decadal Oscillation, or PDO. Again, cooler than normal water temperatures located here, generally to the north of the Hawaiian Islands. And then you have warmer than normal sea surface temperatures right along the western coast of North America. And that includes all the way up into the Gulf of Alaska, off the coast of British Columbia and Western Canada. And all the way down the west coast of the United States, we see above normal water temperatures. And it resembles more of a horseshoe shape here. Let me get my drawing marker out here. Let's see if I can get my little marker or some kind of pen or something to show you. What I want to show you is, let's see what this looks like here. Make sure I have the right color scheme. Generally, you got a horseshoe type shape here. See, I'm drawing this red line here. It's more of a horseshoe shaped ring of anomalously warmer than normal water temperatures all the way in this location here. And then you have your cooler than normal water to the north of the Hawaiian Islands. So again, A very interesting pattern in those sea surface temperature anomalies across the Pacific Ocean. Let's move on. With the negative phase of the PDO, we typically see a sort of a reversal of what we just saw with this phase here, with the positive phase. With the negative phase PDO, it's characterized by warmer than normal sea surface temperatures in the central North Pacific, generally in this location. And then you see cooler than normal now, horseshoe shaped of cooler than normal sea surface temperatures along the western coast of North America. So here it is. This is a negative PDO right here. See how that cooler, darker blue shading exists where it is? And so it's just an opposite effect of the positive PDO. So those are the two different phases of the PDO. And let me go back to my other laser pointer. All right, so moving on now. Let's take a look at, if we just looked at the PDO and what type of winter temperature anomalies we'd see with the various types of PDOs. Let's take a look at that. Now, winter is considered the months of December, January, and February. All right, so during the positive phase of the PDO in the Northern Hemisphere winter, you typically see cooler than normal air temperatures. Now, these are air temperatures, cooler than normal air temperatures across the southern plains, Texas, including you and Arkansas. And then also the southeastern U.S. up to the mid-Atlantic. Notice the darker shading blue here. That's indicative of cooler than normal temperatures for a positive phase PDO. And now remember, the positive phase PDO, we have warmer than normal water temperatures off the west coast of North America, specifically the U.S. West Coast in this example. So wouldn't you know it, we see above normal temperatures right next to the above normal sea surface temperatures here across California, Oregon, and Washington in a positive phase PDO during the winter season. So all the warmer than normal temps are generally right along the U.S. West Coast when we talk about a positive phase in the PDO. And then the cooler than normal temps set up from the mid-Atlantic down to the southeastern U.S., the southern U.S., even you in Florida with a positive phase PDO. And let's not leave our friends of Alaska out here, well above normal air temperatures for you in Alaska as well during a positive phase of the PDO. Let's take a look now at the reverse, the negative phase of the PDO, and what this might mean during the Northern Hemisphere winter. In this case, with a negative PDO, now remember, we're going to have cooler than normal water temperatures off the west coast of the United States now. And so we typically see during a negative phase of the PDO, we see the southern plains right in this location, the yellow shading, the southeastern U.S., the mid-Atlantic even, and even up into the northeast parts of New England. They're more likely to experience above normal air temperatures during that negative phase of the PDO. And we saw an example of this actually this previous winter, the winter of 22-23. We saw a very mild eastern U.S. setup in the temperatures for the months of January and February. And so we had that negative PDO going on this past winter season with cooler than normal water temperatures off the west coast of the U.S. And notice also with a negative PDO, we see below normal temperatures across the Ohio Valley. We see below normal temperatures across the northern plains, including Montana, North Dakota, South Dakota, and Minnesota. We do see a little bit of cooler than normal temperatures across parts of eastern New York State as well. Now look at Alaska during a negative phase of the PDO. It's almost like the opposite of the positive phase of the PDO. Look at the air temperature difference. Above normal winter, below normal for a good chunk of Alaska when we have a negative phase of the PDO. Now look at the above normal is just solely focused along the southern coast of Alaska in this case. Here's a look at the PDO history. This is courtesy of NOAA. The blue bars representing the negative phases of the PDO, the red vertical bars indicating the positive phases of the PDO. And so you'll notice a couple things here that really stand out, right? We talked about the PDO operating on the order of decades as far as the time scale. And for this particular chart, this goes from 1925 all the way up to 2022. What are some major things that really stick out to me is we saw a predominantly negative phase of the PDO, generally in the 1950s, and it was significantly negative. Look how far this blue bar extends down around the PDO index of negative 10 in both 1950 as well as around 1955. So the 1950s had a predominantly negative PDO dominated by these blue bars in negative territory. Also, the 1960s had a negative phase of the PDO. The early 1970s did as well. Before things turned around, where the PDO went predominantly positive in the 1980s as well as the 1990s. Look how significantly positive phase the PDO is here in the 90s. I mean, the late 90s. Wow, this is impressive. In excess of positive 10, between that positive 10 and positive 15 for that PDO index value. Now, 2021, by the way, this is fairly recent. 2021, right here, this featured the lowest PDO value since 1955, and we can attest to that. So you see how far the blue bar extends for the winter of 2022. Now look over here, 1955. Okay, so this 2021 winter season had a very strongly negative PDO as the bottom line. Now the late 1940s, we look in this area to the mid 1950s, had some of the lowest PDO values on record, yielding the coldest winters and the largest snowfalls on record for those of you living in the Pacific Northwest. So it just really goes to show you that the values of the PDO, whether you're in a positive phase or a negative phase, and those sea surface temperature anomalies immediately off the west coast of North America can really have some major impacts to what type of winter you see. And we're really demonstrating that with the late 1940s to mid 1950s. With the coldest winters and largest snowfalls on records, closest to those lower than normal water temps in the Pacific Northwest. Now, let's take a look at the PDO and let's talk about PDO in its relation to other teleconnections or climate drivers. We're going to start off the PDO and the PNA discussion. Now, again, I did a lot of research. These are legitimate research papers, by Gay and Luau. That was one I used extensively on this slide. And then Latif and Barnett back in 1996 as well. Now you can see the Gay and Luau, this was done in 2023, a fairly recent research paper earlier this year. Here are some key facts from their research. Decadal variability of winter cold extremes over eastern North America is mainly tied to the Pacific Decadal Oscillation, or the PDO. So that's real interesting. Positive PDO generally promotes cold extremes in the lower latitudes of eastern North America due to a presence of a positive Pacific North American or PNA pattern. That's what Gay and Luau discovered in their paper. And then the PNA is a prominent mode of planetary scale atmospheric variability over the North Pacific Basin in winter and is closely related to the strength of the Aleutian Low and to PDO. All right, so interesting, we see a tie or connection between the PDO and the Pacific North American pattern. Now, as a reminder, that PNA or Pacific North American pattern is simply whether it's the trough ridge configuration mainly across the United States. So let's say if we have a negative PNA pattern, that means we have an upper trough over the western U.S., colder than normal temperatures in the winter across the western U.S., and more unsettled, more precipitation with a negative PNA over the west. And then downstream of that, with a negative PNA, you have a ridge across the southeastern U.S. up into the mid-Atlantic, and it's milder and drier than normal in the winter for those locations. Now, if we flip the script and say positive PNA, that generally indicates we have an upper level ridge with warm and drier than normal conditions across the western U.S. And downstream from that, in a positive PNA, we get a trough across the eastern U.S. and colder and stormier than normal conditions. And so PDO, what those sea surface temperature anomalies are off the west coast of the United States, and the downstream effects, how the upper air pattern sets up, it's been discovered there is a connection. And I like this bullet here. We talked about cold extremes in the lower latitudes of eastern North America. It's due to that presence of a positive PNA pattern with the positive PDO combined. I'll show you some examples here in a moment of the combined effects. Additionally, the PDO has a high correlation to the Pacific North American pattern, the PNA pattern, kind of what we've already talked about. Now, a positive phase of the PDO, those warmer than normal temperatures or sea surface temperature anomalies off the west coast of the United States, corresponds to a positive PNA pattern with an upper ridge parked over the western North America and an upper trough over eastern North America. So that's going to promote a colder than normal winter in the east and a warmer than normal winter in the west. A negative phase of the PDO, on the other hand, where you have colder than normal sea surface temperature anomalies off the west coast of the United States, that's corresponding to a negative phase of the PNA pattern. And now we have upper trough parked over western North America, colder and more unsettled, wetter than normal, across the west, in this case, with a negative PDO and a negative PNA, and an upper ridge over eastern North America. That's warmer and drier than normal conditions. Now, we just saw this past winter again. the months of January and February particularly, we saw a negative phase of the PDO in conjunction with a negative PNA pattern, and this pattern locked in for quite a bit, quite a few weeks. And that resulted in anomalously above normal temps for the eastern U.S., and then just anomalously colder than normal temps out of the western U.S. And all the snow really last winter, it really, at this point in time, was falling across the Rocky Mountains westward towards the Sierra Nevada, California. Here is some examples graphically of a positive PDO and a positive PNA. We're going to first show you over here the example of the upper air heights at 500 millibars on the left. The blue outlines indicate lower than normal heights. Anytime you see the blue areas here, the blue lines, the red lines indicate above normal heights. So these blue lines here are associated with below normal heights and an upper level trough pattern. The red lines here represent upper level ridge, warmer and drier than normal conditions. Now look what happens when you get a positive PNA. You get a deep Aleutian low. It's positioned a little bit further to the west across the north central Pacific. It's over in this location. It's stronger than normal. It's going to pump in southerly winds on its front side or east side, and it's going to result in a positive PDO pattern where you get warmer than normal sea surface temperature anomalies, SSTAs here off the west coast of North America. So the atmosphere and the ocean, they're connected. All right. So what happens in the atmosphere tends to feed back down to the ocean surface. All right, so here we have an example of upper level ridge over western portions of U.S. up to western Canada. And then downstream from that, we get this lower heights again across the southeastern U.S. up to the mid-Atlantic. And this is associated with upper level trough. So basically what we have here is a trough, stronger Aleutian low, a ridge over the western U.S., western Canada, and then we have a trough downstream from that across the southeastern U.S. And here is the results of the positive PDO, again, associated with that Aleutian, that stronger than normal Aleutian low beneath it there, where you just have a cold pocket of air aloft. Generally, you have colder sea surface temperature anomalies beneath this troughing over the north central Pacific. Downstream from that, you see warmer than normal sea surface temperature anomalies, like I mentioned before, along the coast of western North America. And then you got downstream from that troughing again. So this is really a great graphic, by the way, here. A positive or warm phase of the PDO, the upper air pattern. The jet stream is shown by a yellow line. This yellow line, so you got a dip in the jet stream here with stronger storm activity across the north central Pacific. Downstream from that, you get a huge upper level ridge, and that's going to result right above those warm sea surface temperature anomalies. It's going to result in warm and dry conditions across the eastern North Pacific as well as the western U.S. And then you see a major dip in the jet stream here across the central and eastern U.S. So it's going to be colder and it's sometimes stormier than normal in the winter season. So that's why it's so important to look at this. Now, when you get a positive PDO, warmer than normal temps here, water temps off the west coast of North America, plus this positive PNA, this is an example of constructive interference where teleconnections or climate drivers are working in the same direction. Correlation, by the way, between the PDO and the PNA is greater than 0.80 in the winter months. So it's fairly highly correlated when you get a positive PDO phase with the upper level pattern featuring a positive PNA. Let's look at the opposite now with a negative PDO and a negative PNA. Kind of showing it to you here on just one graphic in this example. But what we have now is we have off in the Gulf of Alaska, off the west coast of the Pacific Northwest, you're seeing colder than normal sea surface temperature anomalies, SSTA, setting up. And then you have a dip in the jet stream. It's a pretty significant dip in the jet stream right off the U.S. West Coast, right into the Pacific Northwest. So you're getting colder and stormier than normal conditions when you have a negative PDO. That's where we have our colder than normal sea surface temperature anomalies. And you get the jet stream dipping down like this, a negative PNA. And so you get colder and stormier conditions. And then downstream from that, you get the jet stream to relax, move further up towards the Canadian-U.S. border, and you get milder and drier than normal conditions across the eastern U.S. All right, so this is also a case of constructive interference where both your negative PDO and negative PNA are working in the same direction. But it's a major difference in how the upper air pattern sets up, which means a whole heck of a lot when we talk about the winter temperature and precipitation anomalies setting up for specific winters. Here again is the negative PDO, and look at this, positive PDO. Look at this. That's a big difference. Here are some examples of the PDO phases over the years. This is going back into the 1930s. I'm just showing you how, again, how we've seen some of the PDOs are some of the decades were dominated by more negative PDO phases, and then other decades were dominated more by the positive phase of the PDO. You can see most recently we had a La Nina plus a negative PDO going on the last couple winters, and we've seen, pretty significantly negative phase PDO here. Over here on the right, I'm showing an example of the PNA index. And anytime you see the red, that indicates a positive filter of the PNA. If it's blue and dips below the zero line, that's a negative phase of the PNA. And so you kind of see, let's just take a look here. Let's go back here in time. Why not? The late 1970s had very, very cold winters in the eastern U.S. You notice there was a significantly higher than normal or positive phase of the PNA in the late 1976, early 1977 time period. And that was a doozy of a winter, 76, 77, the eastern U.S. If we look back here in the 90s, let's see, what is that? It's 1994, late 1994, we saw a pretty significant negative phase of the PNA for that particular winter. And so I don't know what the temperature correlation was. I'll take a look at that here in a moment. But in general, you can see how things change over time here with the PNA phases, whether they be positive, strongly positive, or negative phased. You also notice one more I want to mention before we move on is this fairly significantly strongly positive PNA pattern with the upper level ridge over the western U.S. in late 2009 into, most of the winter of 2009-2010 featured the positive phase of the PNA, and that resulted in some pretty significantly colder than normal temps in the eastern U.S. And then additionally, we saw negative phases of the PNA in the winters of 2013 and 2014, but that featured some significantly colder than normal temps. All right, so now let's look at the PDO and the El Nino Southern Oscillation, or ENSO. Now, overall, during ENSO events, tropical Pacific sea surface temperatures induce tropical precipitation shifts, forcing PNA wave trains. This was discovered by Trenberth et al. In 1998 research paper. This is going to result, these tropical Pacific sea surface temperatures and these anomalies, how they induce precipitation shifts in the tropics. It's going to force various phases of the Pacific North American pattern, PNA pattern. This results in altering air temperature, wind, humidity, and clouds in the North Pacific. And that was conducted by Lau and Nath, the research by them in 2001. Now, during El Nino, the Aleutian low pressure is typically stronger than average during the winter. And this favors a positive PDO pattern due to a stronger southerly winds along the U.S. West Coast. I mentioned this earlier in the presentation. I said, the stronger the Aleutian low, the stronger the southerly winds on the front side or the east side of that Aleutian low, that counterclockwise circulation. That's going to lead to potentially a positive phase of the PDO or higher than normal sea surface temperatures out along the west coast of North America, specifically the United States. Now, during La Nina, which we've seen the past 3 winters, the Aleutian low pressure system is weaker than average during the winter. This favors a negative PDO pattern due to weaker southerly winds along the U.S. West Coast. So that Aleutian low pressure system plays a significant role, the strength of it, a significant role on what type of PDO pattern sets up off the west coast of U.S. during the winter season. Here's a nice little slide. When I combine PDO and ENSO together, when El Nino peaks during the winter time, the North Pacific center of the PNA deepens, resulting in a positive PDO phase by causing variations of evaporation, wind stress on the ocean surface, and air temperatures in the North Pacific. This was research conducted by Strong and Magnestoter in 2009. Now, here's a nice breakdown or summation we combine. When we look at just a negative PDO, in general, it's usually associated with a weaker El Nino. We don't have that coming up this upcoming winter, 23-24 winter season. We're expecting a moderate to potentially strong El Nino. So we're not going to have a weaker El Nino this upcoming winter. So that would not favor a negative PDO. We're not going to have a stronger La Nina this upcoming winter either. A stronger La Nina is typically associated with a negative PDO. And remember, that's due to the weaker Aleutian low pressure system in the North Pacific. Now, what happens if we get a positive PDO? We typically have that associated with stronger, longer lasting El Nino. We're going to have a stronger El Nino this winter. We know this. That could potentially lead to a positive PDO pattern in those sea surface temperature anomalies off the west coast. Weaker La Ninas, on the other hand, which we will not be seeing that this upcoming winter, that usually is associated with a positive PDO as well when the pressure gradient is much weaker during weaker La Ninas. So if I'm looking at these combinations, I'm looking at the ENSO for the upcoming winter, the forecast, I'm looking at a stronger El Nino, okay? Stronger El Nino, and it's associated with a positive PDO pattern. That should be interesting to follow. None of these others qualify. We won't be seeing a weaker El Nino like I mentioned. We won't be seeing a stronger La Nina this winter. We will not be seeing a weaker La Nina this winter. This is the best fit. Look at PDO and ENSO, just showing you the examples. And what I'm doing here is I'm showing you PDO in the upper left and the various phases, again, going back to the 1930s. And the bottom right here, I'm showing you the Oceanic Nino Index from 1990 to present. All right, so really, if we want to pay attention to this graph here in the upper left, I would pay attention right where this red dot is. This is 1990, basically. Moving forward to July of 2023. You see that we're really significantly in a negative phase of the PDO, though. I mean, look how strongly negative things have been here recently. All right. And then look over here on the bottom right. All right. We have the super El Nino, super strong, very strong El Nino, 97, 98. We have the very strong super El Nino there, 2015, 2016. And anything in excess of 2 degrees Celsius temperature anomalies in Nino 3.4 region, that indicates a very strong El Nino. So we've had them in 97, 98, and 2015, 16. Now we've had moderate scale, moderate scale El Ninos in 94, 95, 2002, 2003, 2009, 2010 was considered upper end moderate El Nino. And I really think that this upcoming winter, 23, 24, is resembling more closely potentially to this 2009, 2010 winter season El Nino. I do expect it to be a strong El Nino, but we do expect it to peak in the November, maybe December time period, early winter, and then start coming back down in strength, the El Nino. We look over here, we're also showing you La Nina winters as well at the very bottom here. So in the most recent winters, we've seen a La Nina for 3 straight winters. We're not going to see that same atmospheric pattern set up for the upcoming 23-24 winter with El Nino. Let's combine some things now and look at temperature anomalies for the United States. When we get a positive PDO along with a positive PNA pattern, this is January of 84, and look how below normal temperatures were all the way down to the deep south and the eastern U.S. We did see with that positive PDO, warmer than normal temps off the west coast of the United States, water temps, we saw above normal temperatures, slightly above normal along the west coast of the United States. We take a negative PDO now and combine it with a negative PNA, and you know what? Let's do the trifecta here, and let's throw in a La Nina now. All right, so we have a negative PDO. That means we have colder than normal sea surface temperature anomalies off the west coast of the United States. We have a negative PNA pattern. Remember, I already mentioned from the previous research a couple slides ago, these two are generally connected. Negative PNA, upper trough along the western U.S. A negative PDO generally promotes cooler than normal temperatures along the western U.S. as well. So that checks out, and then La Nina. La Nina winters are typically milder back in the east here, okay? Specifically here along the mid-Atlantic. But look how much above normal things were east of the Rockies in January of 1989. It's crazy, isn't it? We look at a negative PDO plus a negative PNA. So again, we got the colder than normal water temperatures off the west coast of the United States. We have troughing with a negative PNA over the western U.S. This makes a lot of sense. Much below normal temperatures for January of 2013 across Utah, Nevada, southern Idaho, as well as into parts of eastern Utah and western Colorado. Look at this. East of the Rockies, though, a different story. January 2013, above normal temperatures. So this does make a lot of sense. It checks the blocks. We expect this kind of temperature anomaly set up in the U.S. with these two going on at the same time. Let's take a look now at the negative PDO plus a negative PNA plus a La Nina. And it's going to be similar to what we looked at here, except we're going to look at a different winter month. We're looking at December of 2021. This is fairly recent. By the way, the PDO value in December 2021 was negative 2.71. I just threw that on here. But in general, we'd expect negative PDO would have cooler than normal water temperatures off the west coast of the U.S. I'd expect cooler than normal temperatures already just based on that. Then we throw in that negative PNA pattern. That means we should have troughing over the western U.S. Now, what's interesting, in December 2021, we don't see those below normal temperatures extending very far inland from the coast. So maybe this particular month, the trough set up much further to the west, and maybe just a piece of that trough moved in along the immediate west coast. But we don't see anomalously below normal temperatures here in the western U.S. with that negative PNA pattern. Now, La Nina, again, typically brings milder temperatures in the mid-Atlantic. This is matching up well with what we'd expect with a La Nina winter, or the circulation pattern inducing this type of setup. Now, this is some crazy warm weather here for December, generally across parts of the Ohio Valley southward to the Gulf Coast. I mean, 10 to 13 degrees Fahrenheit above normal mean temperature anomalies in December 2021. That's pretty significant. I believe this was the month also that we saw the Mayfield, Kentucky tornado that unfortunately did some damage to those plants where those workers were located in. Let's take a look at negative PDO and a negative PNA plus another La Nina winter month. This was January of 2023. So this is fairly recent. This was the past January. Negative PDO. So we have below normal water temperatures, colder than normal water temperatures off the west coast of the United States. Check. We've got a negative PNA troughing along the western U.S., which was very tough to break. Check. Below normal temperatures here in the blues and the greens. Yes. And then La Nina, milder across the mid-Atlantic. Check. This all checks out to the type of pattern that we would expect to see with all three of these constructively interfering with each other. Now, let's take a look at negative PDO and a positive PNA. Negative PDO versus and a positive PNA at the same time. This is going to result in destructive interference, okay? What do I mean by that? I mean that these two teleconnections or climate drivers are not working in the same direction. So with a negative PDO, colder than normal water temperatures off the west coast of the United States, we should have colder than normal air temperatures right along the west coast. Now we see milder than normal temps, slightly above normal, across central and southern California in January of 2000 here. We should see, with a positive PNA pattern, we should see ridging, however, over the western U.S. Okay, so that might explain why we're seeing these above normal 5 to 7 degree Fahrenheit above normal values for the mean temperature anomalies across Nevada, Utah, as well as parts of Colorado and Wyoming. All right, with a positive PNA, we'd also expect colder than normal temperatures and troughing, upper troughing across the east. We're seeing that in December or January of 2000, rather. We're seeing those below normal temperatures in the eastern U.S. associated with a ridge over the west and a trough over the east. But the negative PDO, it wants to say, wait a minute, we should have a negative PDO is most normally affiliated with a negative PNA. So this is a case where these two teleconnections or climate drivers offset each other. That's known as destructive interference. Sometimes what it takes when you have a destructive interference situation is which one of these is stronger, has a stronger influence on the atmospheric circulation in the mid-levels of the atmosphere, the negative PDO or the positive PNA. In this case, I kind of favor the PNA based on this cooler than normal regime of temperatures across the eastern U.S. What happens if we take a positive PDO, a positive PNA, and a very strong El Nino? Now, this happened in December of 1997. Positive PDO, okay, and a positive PNA. Those are usually associated with each other, okay? So those kind of go together. But then a very strong El Nino as well. So colder than normal water temperatures here off the west coast of the United States. I'm sorry, warmer than normal water temperatures. I'm getting mixed up here. With a positive PDO, we have warmer than normal water temperatures off the west coast of the United States. And those do typically tie in during El Nino events. You get a PDO with El Nino events. So those kind of go together. And then you have a positive PNA. So that would mean that we'd have ridging over the western U.S. and we'd have troughing over the east. We didn't quite get that this particular month, December 97. To me, it looks like we had a very active subtropical jet with a lot of clouds and precip here in the southern, more of a southern storm track from coast to coast, and even slightly below normal up to the mid-Atlantic, and the well above normal air temperatures. And this is normal for El Nino. If I look at this particular temperature anomaly graphic or chart, I'm definitely thinking El Nino here. And I wouldn't even have to look this up because this is really an ideal looking El Nino pattern. Colder than normal southern U.S. along the storm track, and then warmer than normal up here into northern U.S. as well as up in Canada. So in summary, you get a Pacific North American PNA and the ENSO, El Nino Southern Oscillation. Those two teleconnections are typically associated with a PDO, and that's really why I zoned in after looking at the research papers that were out there. When I talk about PDO, Pacific Decadal Oscillation, I tie it in with these two main Pacific teleconnections, the PNA and the ENSO. The sea surface temperature anomalies off the west coast of North America are related with the PDO and specific PNA phases. A negative PDO is affiliated with a negative phase, the PNA pattern, so we get upper troughing over the western U.S., along with wetter and cooler conditions there. And then downstream of that, we typically, with a negative PDO and a negative phase, the PNA, working together, we would expect to see a milder and drier than normal winter in the eastern U.S. On the other hand, positive PDO is affiliated with a positive phase of the PNA pattern. So in these particular winters, you get upper level ridging over the western U.S., along with drier and warmer conditions there. Downstream with a positive PNA and positive PDO, downstream over the eastern U.S., you get wetter and colder than normal conditions during the winter season. Now, El Nino is stronger and longer lasting during a positive PDO, and La Nina is stronger during a negative PDO. So notice how these two connect. El Nino is stronger. When it's stronger and longer lasting, you get a positive PDO. When La Nina is stronger, you get a negative PDO. Now, the El Nino favors a stronger Aleutian low pressure system. This results in increasing southerly winds off the west coast of North America. This is going to promote warmer than normal sea surface temperature anomalies. And what does that mean? Warmer than normal sea surface temperature anomalies along the west coast of North America means a positive PDO. And that then ties in with a positive PNA pattern. So El Nino, positive PDO, and positive PNA all working, constructively interfering, working in the same direction, in phase. That wraps up my video this evening, covering the PDO, the Pacific Decadal Oscillation, and then looking at various other Pacific teleconnections, PNA, and the ENSO, and kind of looking at the relationships between all these, right? Additionally, looking at just PDO alone. Let's go back here. We look at just PDO history and the phases, the general temperatures you'd expect. Positive phase PDO, you're getting colder than normal eastern U.S. winters, whereas you get milder eastern winters when you get a negative phase of the PDO. And then just kind of going through the history, you notice PDO tends to operate more on decadal timescales. I'm really, really intrigued by this one right here, the summary. When you combine PDO and ENSO, we have a stronger El Nino this winter. Will that lead to a positive phase of the PDO? That one remains to be seen, but that could be huge. That could have huge implications on the winter season for the United States. All right, everybody. Thank you so much for watching my latest video here at Spot On Weather YouTube channel. Keep your eyes on the sea surface temperature anomalies between now and the start of winter. And we're going to see how the upper air pattern sets up, where the jet stream sets up, how the upper level winds set up over the course of the next winter based on the PDO phase. I'm really curious. And then also the El Nino, the strong El Nino that's supposed to happen here coming up. So a lot of excitement in the air with, future teleconnections discussions. One thing I wanted to mention before I go, my next goal, I'm waiting for all of the long-range seasonal models to come in for the upcoming winter, December, January, February, those months. And I'm going to put together a video on the long-range winter forecast. And we are going to go through the video and then we're going to compare them month to month. So I'll do a video on long-range winter forecasts from some long-range seasonal models for September. Once I get them all, we'll look at October's forecast when that comes in, November, and we're going to see how and if it changes. And we're also going to look at the end of the winter, which one of those long-range seasonal models actually was the most accurate. So I'm looking forward to that as well. All right, that wraps things up at Spot On Weather. Thank you so much again for subscribing to my channel. Until next time, take care and God bless everyone.